let's see. So basically, what I'm gonna do here is Control D. This is the wrong combination of keys. So workspace, Android, course. Oh, sorry, workspace, Coursera, Android coding. Now, what I have that file ls*trace. To analyze it, we use trace view, and then yamba.trace. So this is the tool that shows you what's going on with the execution of your code. Okay, so a couple of things. You can see that the whole thing took about 10 seconds, right? Secondly, what we have here is another thing to notice is that we have one thread here, which is also known as the UI thread or main thread, okay, that everything is running on. You can kind of ignore these binder threads because this is not really us doing anything. So everything is happening on this one thread, okay? And this is true for services, activities, broadcast providers, broadcast receivers, content providers, everything runs on the same thread. So that's why I got to be mindful of this. So what you are looking for is things that take forever, right? So for example, there seems to be something that is sort of long-lasting here. I can zoom in, and you can see that these are all a bunch of methods here. This is something else. So let me see if this is one task. No, that's not what I was looking for. But we can basically look for things. So this is collections. You can also search in here. So we can search for things that are running. So activity on click. This is where we click on click. This is where we are doing network stuff, right? So this seems to be the network-related activities, right? So this is basically the idea is that we can identify the possible bottlenecks, right? For this particular thing. Now we had just a failure, so it wasn't really blocking for that long of a time. Okay. But the point is that everything is running on the same thread, on one single thread. Okay, there's our exception, and this is where we're trying to get online. Okay, we're not getting any connection in this case. So that's execution on a single thread. Now you guys notice that that's running slow. So what we would want to do is we would want to put this on the secondary thread. So how would you do? Oops. How would you do that in Java? What would you do here to make this run? I mean, one simple thing could be you could say new thread. New thread. You can basically do .start. You can put a run method in here, right? Public void run, right? And then you can basically move your long running code into here, right? Something of that nature. Now the result is something that we need to basically move up. And yeah, so final result. So there we go. So that's exactly what I was. That's exactly what I was. That I was getting at. So the problem with this is that once we get it to run, is that it would fail because the well, yeah, exactly. I mean, I could put the toast into here, but that's exactly what didn't really want to do. In this case, this refers to the inner class itself, so we need to say status activity dot this, right, to get around that. And then final, this doesn't need to be. Or I can just move it in this case, right, in that, or just here, and that solves that. So this everything compiles, right? But if I run it, this would not work because I'm trying to update UI from a non-UI thread. So that's the problem. And like you guys said, it needs to be synchronized at some point. So let me kill this trace view. So we're gonna retest that really quick. So test. Oops. You could, but you're basically then recreating. You're doing a lot of work potentially. So this did now put it on a separate thread. Okay, but it's not failing yet. Okay, and it's not going to be able. So there we go. It finally crashed. So if you look at the crash log, the problem is that there are multiple problems. But so can create handler inside thread that is not called a super. That is one of the problems. So essentially, we cannot update the UI from the non-UI thread. Okay. So yes, we could do some manual work to synchronize the threads and merge them together, join them together. But there's sort of a built-in mechanism for that. And the built-in mechanism is something called async task. So let me show you what that looks like. So I'm not going to do this whole thread start, new thread start business because it's not really what we're working for us. So reformat. Okay. So what I'm going to do here is I'm going to create a new class, and I'm going to call it, I don't know, post to Twitter extends async task. Okay. An async task sort of has three components. It has what you're passing in as the work, what the intermediary result is, and then what the final result is at the end of the day. So I could say what we're passing in as work is post this status. So it's going to be a string. I don't know if you guys can see. Let me put some space there. So it's going to be a string. We're not going to have any real progress report because we don't get. So the second parameter is for a progress report, right? Like if you're downloading a file, it'd be like 75% done, right? But we don't have that data. It's not like Twitter is telling us, I'm almost done posting, right? It doesn't. So I'm going to avoid it. And the final one is going to be a string that basically says we're done with updating this is the result, right? Worked or didn't work. So let me organize imports to include the async task. And let me add unimplemented methods. Bam. So the main method is do in background. So what is that we want to do in the background, right? And that would be your long-lasting job. So in this case, the long-lasting job is going to be this, right? So that's what potentially takes a long time to process. So I'm going to cut it out, and I'm going to put it in here, and then whatever the result is, I'm going to return. So return result. Right? So that's that result, right? So whatever the result is going to be returned. Now the input is going to be the status that we are posting. So this is really status. So, but it's an array of arrays, right? So that's why I have to say status 0, right? And now that's my long running task. Okay? And then you can have this two other methods that are kind of useful. One is on post execute that gets called when the job is done, and the other one is on a progress update. So like I said, we don't really have a progress update, so I'm just going to say on post execute, right? And this is a good place to get that result and do something with it. So that's something that I'm going to do with it, is that toast line. So I'm going to cut that line from here, and I'm going to basically say, so now I get to change this back. So that's that result, make text show. Oh, sorry, that was actually correct. That's exactly correct. Yeah, so this gets run on a separate thread. This gets run on the UI thread. So that's why in this call, we can do anything we want to the UI. In this call, we cannot touch UI, but this is where we put the long-running stuff, right? So this is now fairly safe for long-running tasks, right? It's gonna run, can run for a while. So what I'm gonna do is now, I don't really need the final here anymore. So what I'm gonna do now is I'm gonna create that class, so post to Twitter, right? And I'm gonna say dot execute, and I'm gonna pass status to it. Okay. So this is now running on the long-running task. And by the way, I gotta move this because it doesn't belong here anymore because we wouldn't see anything. I'm gonna put it at the bottom of this, right? For now. So let me just kind of walk you through this before we run it. So now we are saying post to Twitter some kind of message. That message is now an input to here, right? Okay, which is what we now use to actually do the long work with. Okay. Now when we're done with all that, the result, let me do a different color. The result is that result or this result, right? It doesn't matter which one. Ultimately, it's a result that gets passed into here, and that's the result that ultimately we're going to print out on the screen. Right? So basically on one hand we have the input, which is the status, right, that came from the job, and that's what's running here. On the other hand, we have the result that is coming out of here. Why is this dot dot dot? Yeah, that's how they designed it. So I could then use this to run multiple statuses. Another status update, right? So you can have variable length arguments. That's just how the API is. Because presumably you'd say like post and then 2, 3, 5 jobs at once, right? Is this kind of making sense to everyone? So hopefully this is sort of like a sugar-coated, nicely packaged way to do, multi-threaded operation when you need to do it on a UI thread as well.
Can you return something other than a string?
Yeah, absolutely. Can you return something other than a string? Yeah, I would need to change. So this guy corresponds to this guy. Okay. This one corresponds to something we're not using on progress update, but this guy corresponds to this guy, which is the result, right? Which corresponds to what the input, which corresponds to that, right? Which corresponds to the input that we have here, right? So that whatever. So if you wanted to return long, for example, I don't know. If you wanted, see now this is wrong and this is wrong, right? So I could basically change this to long, and I'm not gonna do it, but that would be, you would need to change that, and that would work. What does calling on super on post execute do? Presumably whatever is need. So let me see. I may get away without having to call it. I'm not sure. Sometimes for some on methods, on lifecycle methods, you must call super. So, but in this case, I'm not sure if it actually does anything. So let's just run it and see what happens. I took it out. I believe I don't even need it in this case.
That's not an Android thing, is it?
That's a Java thing. That's a Java thing, yeah. But I mean, it's an Android framework, so.
Async is?
Oh, async is an Android framework, yes. Right, because it's specific to the UI, it's specific to synchronizing with the UI thread. So it's definitely, so hello from multi-thread update. See, dim block, see, that worked really fast, right? And you know, we're waiting to see if it's gonna pass or fail. Again, it doesn't really matter, but we just need the data back. So that should be done sometime soon. I'm expecting a toast.
Is it on because that super had the async joining?
I don't know. It could be just the trace is really changing the game here because it just takes a while. So trace stopped. Let's see. So let me see if I have the latest trace, 16, 17. That sounds pretty recent, right? So I'm gonna analyze this trace. I'm gonna assume it worked. So this time around, I'm gonna do this. I'm gonna use the command line to get the trace. So I'll say ADB pull, right? Because I told you can do both, right? So SD card yamba.trace dot IDB dash e pull. Okay. So that's my file. So I'm gonna say trace view that file. Let's see what we got. All right, so see now we have a different picture, and the notable difference is this. Oops, is this here, right? And you can tell that that long-lasting job got pushed to a separate thread, right? So that's that long-lasting job. So I'm gonna zoom in here, and you can see that these are mostly NIO, IO calls. So there's our Twitter calls, Twitter dot start and etc. etc. So there's a network URL encoder. So those are definitely our network calls, right? INET address and so forth. So, but as you can see, it's running on a separate thread. That was the whole point of this. So is there a way to queue up requests on an async task, and so you only have one? Not really, that I know. But what you can an alternative to async task, it's not really an alternative. Another way of doing things is to create a looper, and then you get you can basically post jobs to be done later on. So you can queue them up using the looper because that's what it is. It comes with a queue. So if you spawn two threads, is there a way to know which one you're getting the status back from? I believe this is supposed to be synchronized with one another. So this is gonna call this, so it's within the same object. Pretty sure about that. So this guy is most definitely going to invoke this guy in the same object.
The second one finished before the first.
Yes, it's absolutely possible to second one to finish before the first. That's absolutely right. And but they're gonna call their own respective methods. It's not gonna be the same data, right? So which one? I mean, they could identify themselves somehow, right? So we could put some kind of identifier, and it could say this or that. I believe you can actually put a constructor in a post to Twitter, sort of like a thread, and give it a name. So as opposed to being async task number one, number two, so you can identify that way, right? Or simply you can give them a counter or something, right? So it could be static counter, and you can just jack it up by one. So but they're two separate objects calling their own respective methods. Any other questions with respect to this? Now there was a question, an interesting question about timers and services and so forth. So there is you know, when I did in Yamba, when I did a updater service, when I did an updater service, that's the service that wakes up every minute, for example. Right? So here, see, I give it a name. This is just for Java purposes, so I know which thread is which thread, right? But you know, in this case, I don't need anything fancy as an async task. I just basically have a separate thread that's running in the background, and it's pulling data from Twitter, right? It's running on a separate thread, so it's not blocking UI thread. But it doesn't require any synchronization with the UI thread, thus no need for async task, right? Okay, so this is just a plain old Java thread, nothing fancy about it. However, this is not very efficient because you know, I have there are a couple of reasons why this is not very efficient. For one, it's a process that's always on, always running. Okay. Secondly, so it's taking some memory even though it may not be doing anything at all. Secondly, it's not very smart because it's got a time, it's got a life of its own in terms of how frequently it wakes up. The better way to do that would be to use to synchronize my own going online with systems going online. The reason for that is the battery, right? So firing up the radio is very expensive. I mean, if you there are stats on the consumption of battery. I forget what it is in units, micro milliamperes or something. But you go from like 10 to 110, so it's order of magnitude more power consumption when the radio is on. So one of the things you want to do is you want your app ideally to synchronize with everything else on the system when it goes online, right? So when Gmail and Gtalk and weather app and widget and all that need to get information, it's much cheaper if everything synchronizes, fires up the radio, does the networking shutdown, right? So to do that, I actually use something called an alarm service. To say, hey, wake me up on certain intervals, and it doesn't have to be exactly a minute, but approximate sort of time span. Because in this case, we don't really care about the specific time span. Approximate is good enough, right? But I'd rather synchronize it with those system calls. And then that alarm, what it does is it sends an intent. And then there's something called an intent service, which I have. So I think Yamba 8 is actually using that. So I go from regular service to an intent service. So what happens here is I have a new kind of service, intent service, which basically has a method called onHandleIntent. And as opposed to worrying about this, like wake up every once in a while, blah, 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 it basically just says, when it's time, wake me up and do the updates. It does the updates, right? So basically, the service itself becomes much simpler, but it requires an alarm to wake it up every once in a while, which is a system service, which is a different kind of ballgame. I mean, not different ballgame, but that's it's something that we need to kind of worry about. So we need to register it to the alarm service and so on. So, so does that kind of answer that question? So there's a different approach altogether.
So where do you register?
The updater service is registered, I believe, in Yamba app. Let me see. That's a good question. I'm not sure if this code has it. So, oh, I know. I think I do it actually in the boot receiver. Yes. So this is where I registered it. So basically, when the system boots up, I say, all right, let's get the alarm service, and let's tell the alarm service to inexactly repeat, every so many intervals to send a pending intent. So it's an intent that you send for the future, right? So you have an intent, and you can send an intent, but you can send an intent. You can also leave an intent to be sent in the future. So basically, I'm giving this alarm an intent to send in the future to do something, right? And that pending intent is basically get service, and to call the updater service with a pending intent. So that's what it does. If you're doing an animation, you wouldn't do intents, probably, because intents are asynchronous, right? So it really depends, but yeah, so this wouldn't be really appropriate because you don't really know when it's going to happen, right? That's a big difference between an intent and just a function call, which could be a remote, IPC call, but those are blocking, asynchronous, and these are asynchronous. So that's why you wouldn't necessarily do an intent. So if I would basically do it programmatically. So you would just loop through it and say, hey, do this, right? Not necessarily. It's not necessarily blocking. That's a good question. Let me show you. There's an example that I also have in there called Compass. Let me show you. I'm gonna run this on my physical. Oops. Well, I'm gonna run it in the emulator first, but after that I'm gonna run it on my physical phone. So this is a little Compass application that it's on the emulator. It's not gonna do much, but it basically just shows the rows, right? So let me run it on the physical phone because it's a little more interesting. And then I'm gonna close these, and I'm gonna turn over to this, and I'm gonna pull up the buffer. So you can see this is my compass, right? So it's kind of supposed to be pointing north. I mean, it's not the most accurate thing in the world, right? But as I'm moving the phone, it's rotating, right? And it's actually pretty smooth on, well, relatively smooth on here, right? So you can kind of see what it's doing. I have to do a refresh because it just grabs the screen buffer. Yeah, it's just pulling the buffer. It doesn't update in real time, but you can kind of see in the real time that that's what it looks like. So let me just show you the code for this because that kind of answers a couple of these questions. So what happens in Compass is it also demonstrates a custom component. So first of all, so we have an activity, it's listening to a sensor. So first of all, notice that I do not have any XML in this case. You guys were asking, do I need an XML to create a UI? You absolutely don't. As a matter of fact, I even deleted the default ones from here because there's no layout in here. So I do not have any layout. I do it programmatically. I say set a content view for this app to rows. And rows is something that is custom. It's a custom component here. It's a widget that doesn't exist in Android, right? I created it. So, and just like in Java, it works very similarly. So if you wanted to create your own custom widget, in Java you would subclass component, right? In Android you would subclass view, right? In this case I went a little higher up, so I subclass image view because I'm dealing with an image. And I set, the image resource to. So in this case, this was another question you guys had. See, in this case, I'm pointing to just drawable. There's no drawable dash, high, low, medium density. I just have one drawable. Okay. Now, what I also so basically, just like in Java. What I have here is I have onDraw method. So just like in Java's component, when you want to have a custom component, you override the draw method, right? Works the same way. You override draw method and you say you get a canvas and you get to draw on that canvas. I think you get graphics, right, or canvas, I forget. So same idea. So graphics or canvas is your basic sort of canvas. You draw lines and circles and dots and pixels and things like that on it. So here what I'm doing is I'm on draw. I take the canvas, I get its width and height just to figure out the middle point, and I rotate it around its middle point. So I take the canvas, I rotate it around its middle point, and then I do whatever the parent was going to do anyhow. Draw on that now rotated canvas. That was my logic behind it. You could have also drawn like rows if you wanted to do some math and stuff, but I didn't really care. I just found an image on the internet and used it, right? So that's it. That is the draw method. So rotate the canvas, draw on it. Okay. Now the guy that's driving all this, so this guy just puts the canvas at its. So this is the only one component that we have is the content view is going to be this rows. So here I'm getting a sensor manager. So this is a system service. I subscribe to it on resume. I unsubscribe to it on pause. Remember when we talked about this here? I said sometimes things are expensive and you want to do them only here, right? That's why processing the sensor data, there's just like so much data. Are you sure you want to listen to it all the time, right? So I basically subscribe on resume and unsubscribe in on pause. So the only time I'm actually cranking through the data is while I'm visible, right? So that's why I go in on resume, okay, and I go out, do the opposite in on pause. It's like the same way if you do location or whatever, just the names change as opposed to register, unregister, or maybe listen, unlisten, or whatever it is, right? But same idea, same concept. So, I register notifications. I provide this as the listener, right? So when the sensor gets changed, I get the sensor event. I figure out the actual, or not GPS, but angle of the sensor, orientation, and I say I set the direction in that rows object. In the moment I set the direction in the rows object, that orientation, I also invalidate it. So this is now back to answer your question: is this going to run? Is this going to block? So this invalidate inadvertently calls on draw. Same as in Java, right? So in other words, component doesn't say draw me. Component says, look, I'm not valid anymore. When you get around, fix me up, right? So the component just invalidates itself, just flips the switch. That's super fast. Says no longer good, need a redraw. Add some next cycle, whenever that next cycle is, it's gonna redraw. But this is faster than actually posting, doing intents, right? Because it's just within a component itself. You could invalidate from another thread, given that you have access to it and all that and everything. Yeah, there's an interesting. If you guys do any NDK work, there's an interesting example that is using the plasma. It's drawing, but it's drawing in C, and so it's drawing in C, presenting in Java, and as soon as it displays it, it invalidates it. So basically, it's creating an animation just by the sheer factor of invalidating itself forever, right? And kind of demonstrates how quickly it can, how many frames per second it can do. It's called Plasma. It's a demo in NDK. So that's how this works. One thing that I wanted to show you also in terms of so we talked about this linear layout. There's some other layouts like table, frame, and so on. I'll get back to this, but one thing that I wanted to show you, since we're talking about debugging and all that, we talked about logcat. Debugger is just your standard debugger, trace view. There's a tool called hierarchy viewer, and it works like this. Let me show you. So I'm going to kill this one because we no longer need it. Again, all these tools are in your tools directory. Let's see if it's going to work. Oh, it does work, hopefully. Okay, so it's loading data. So what I'm doing now is I'm attaching to the currently working device, and I'm looking at its hierarchy, right? So let me show you like this. So let's see. Let me show you like that. Let me hold on. Let me just use something older, because I'm used to the I'm used to this hierarchy viewer. It's slightly older, but a little easier to demonstrate. So load hierarchy view. So basically, what I'm looking is the structure of my UI, right? And what we're seeing here is basically what is going on the screen. Now, the screen that I'm attaching to is this screen. So super simple, right? We have the phone window, right? We have single frame, and we have the throws, right? But if I go to a bigger screen, like a bigger application, like for example, home application, right? Then things are much more complex. And if you want to see how much more complex they are, you can basically click on Load Hierarchy Viewer here. And it's going to take a little while, but it's going to load up that hierarchy. And it's going to show us the structure of this. And the point of this tool is to basically provide you with a way to see what your UI looks like, because that's one of the things that you want to optimize the most, right? That's where you get most of the bang for the buck when it comes to efficiencies and all that in terms of running code, right? So we talked a little bit about threading. Now it's the optimization of the UI. So as you can see, we have a fairly complex structure. There's like a lot of objects going on in here. You can kind of see that there are a gazillion objects going on. So this is a tool that basically helps you with analyzing what your or somebody else's app may look like when you develop UI, right? More specifically, if I look at our app, let me see if it's do we have it running, Yamba demo. So it's fairly simple, and I can now load hierarchy viewer this one, and I can see what's going on. And what you want to do is you want to eliminate things that are unnecessary. For example, unnecessary nested layouts, things like that, especially if you have them inside of a list, in other words, in a loop, and so forth. So there's a couple of years ago, Romain Guy, who's keynoting tomorrow, he did a talk called Turbocharging Your UI. So it's a very good talk for any sort of stuff related to this. So it was a talk at Google I/O, so you can easily Google it. But I recommend looking into that. And now I forgot about the trace view, but that's basically why everything's running a little extra slow at the moment, which I should probably comment out so that we don't have that anymore going on. So let me just comment this out. There we go. So this is our UI, right? So it's fairly basic. So you can double click on a specific window, and it shows you what that window looks like, right? You can look at what is this part of my window, and you can see just that part, right? You can double click on what is that part? Oh, that's our button, right? And so you can analyze the UI this way. You can find inefficiencies and fix them. And usually you can fix them by using a smarter layout. So I kind of stuck to the very basic layout, like I mentioned. In this case, with the linear layout, right? But you can also use some more intelligent layouts, such as a relative layout, which makes it easier for you to use a single layout for more complex UI as opposed to nesting layout within a layout within a layout. So this tool, hierarchy viewer. So no, there's nothing you have to do about enabling these tools. They're basically in your tools directory. To expose them to Eclipse, I'm not using Eclipse in this case. So I haven't been using Eclipse. This is a separate tool I'm just launching from a command line. There's no button for that I know of in Eclipse, but who cares, right? You can double click on an actual executable in your tools directory. Yeah, so profiler, there's a way to profile right from here, so you can basically do certain profiling right from here from the devices in the Eclipse in the devices directory. Okay. So those are a couple of things that I wanted to cover with you. So we talked about hierarchy view, trace view, the async task. We have any other questions, any things that you guys were interested in? I was going to show you some more cosmetic stuff, but I wanted to kind of leave the last 15 minutes or so for any questions and stuff. Yeah. I use a tool to connect my real device to a computer.
You connected your actual phone to your computer.
Yeah.
And then you had some tool where you're able to view the screen grab. You're able to view what's on your mobile screen.
So that tool is DDMS. So there's no special tool. Again, we're agnostic to the device. So as long as your device is enabled for USB debugging, right? I can see the same tool. I can click here and say, give me this screenshot of my emulator. So this is my emulator. Or I can say, give me a screenshot of my device. And this is my physical device. So you don't really care about the physical device. In other words, you don't really need the physical device unless you're doing things that are not very well supported. For example, sensors is not supported on the emulator at all. So that's where I kind of need it. So sometimes, connecting a physical device, sometimes you need the USB drivers. I didn't because I'm on a Mac, but you may need a special USB drivers to connect specific devices. So you can download them as well as part of the Android tools. Every once in a while, what is pretty common is your Eclipse uses connection to your emulator. Okay, and what I see people do is they basically shut down their emulator and restart it. That will do the job. However, it takes a long time to do that, right? It creates friction in developing, restarting emulator. I try not to restart emulator ever, right? So an alternative to restarting an emulator is to basically do something like this. Hold on. You can do ADB kill server. Right, so that is going to shut down the connection between the ADB on your desktop and the ADB on the device, and you can do ADB start server. So that reboots that connection, and in I don't know, half the time, 3/4 of the time, that's going to fix the problem, right? So that's useful because it saves you time. Yeah. Can you do this in Eclipse? Can you start, stop? Is there a button for that? Not that I know. Yeah, I'm not sure if you can reboot directly from Eclipse. Oh, okay, you can. So.
I think it's the stop. See the stop push button on the toolbox. Up a little bit.
This. Not that I know, but right now it doesn't. So let's see if you're connected to. It says it's online, but yeah, it doesn't. No, it doesn't. Stop process. Let's stop a specific process. So I can go select the process and kill and stop it. Right. Yeah.
Click on the debug view. I think is the.
In the debug view. Yeah, I'm not sure, but I'm kind of used to just doing it on a command line. So, there may be a button for that. So receivers. So the world's simplest receiver probably is that boot receiver. Let me show you actually. Let me show you another example altogether. How about this one, SMS receiver? Because that's something you guys can easily relate to, and I don't need to restart my emulator to demonstrate. Because boot receivers started at boot, right? So I'm gonna run this on the. I'm gonna run this on the emulator. Now it'd be nice if I can actually fake sending an SMS to the emulator. So, but you know what? This time around it may actually work because I think it was failing because I didn't have 3G last time, right? So let's see. So I installed it. It doesn't say anything got installed. It's not running because this app, unlike this app, doesn't have any activity. Unsupported. Okay, so unsupported XML files. So open with text editor. I'm not sure why it's not supporting it. See, I have an application that all it has is a receiver. And it basically says filter for SMS received. This is my this is my subscribe part. I'm registering this receiver with the system just to receive that, right? That's my registering. Now, when the system gets notified, it's gonna call this guy SMS receiver, which is a simple piece of code here. Okay. Now, what happens inside of onReceive, I don't want you to worry about. Those are intricacies of actual SMS processing, and as such are not important. Okay. But simply, you know, we are registering it here. We're saying let there be an SMS receiver. Let it filter for this system intent called action called SMS received, for which we also have to have a permission to receive, right? And when that gets received, this is going to get triggered, woken up here. So let me see if I can demonstrate this by going into the DDMS and saying, let's send this guy an SMS message from 555-1212, and I'll say, hello there, okay, send. Okay, so there should be two notifications here. This is mine, okay, this is systems. Did you see that? So the toast was mine, and I may also have a system message, I'm not sure. No, this is I think this is a system notification that's going to open up the SMS in the system. Mine just does a toast. I had a version that also does this, but this opens up messaging and so forth. But basically, one broadcast, two receivers, the system SMS and my SMS, right? Does it make sense? So very simple, yeah. Would it be possible to supersede SMS? Consume it, yeah. Could one, so it's a broadcast message. So I'm not sure if you can actually, by definition, broadcast messages go to everyone. So could you basically consume it from everyone else? You have no guarantee of the order, per se. So, but I'm not sure if there's an API to actually consume it and remove it. But I doubt it. I'm not sure. Yeah. Broadcast receiver and what? The alarm. So what's the difference between a broadcast receiver and alarm? So alarm is a service. It's one of the system services. There are many system services such as, you know, Wi-Fi service, telephony service, camera service, sensor service, Bluetooth service, location service. They're all different services that provide different, they're part of the app framework, and they provide different functionality, right? Very specific to that, each of those domains. Alarm service is a service that, it's kind of, think of alarm service as a cron job. Okay, so it's a cron job. So you just say every 5 minutes, every half an hour, every once a day, do something. Send an intent. Bam, 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 right? So it's very periodic and so forth. Broadcast receiver is very different. It's basically a publish subscribe. So it's dormant, doesn't run, doesn't exist, may never get woken up. But if a certain condition is met in the system, so there's an intent for which it's subscribed, it gets woken up and does something. So it's very, very different sort of functionality. So it's as opposed, and then you have a regular service, which is sort of maybe like doing prank in the background, right? Like something like that. Yeah, back. Yes, you can. So there's a sample code as well that I have. So for example, if I have this, where am I? So let me run this, where am I program? Lately this hasn't been working, but let me see, on the emulator. So I have a little program that says, okay, what's my location? And it tries to figure that out. by default it doesn't know, it's waiting for GPS. So one way to fake it is to basically go here and you can say send the coordinates. And that technically should start the GPS, open up the GPS, and we would get those coordinates. But for some reason, it doesn't seem to work on this device, right? If I run it on my physical device, we can see the different result because it should. Well, I'm not gonna get GPS. Oh, target unknown. For some reason, it's not connecting to my device. So it's offline apparently. I'm not sure why, but that would give us a different result on a physical device. So yeah, you can fake it in theory, but it doesn't work that great sometimes. Yeah. So in terms of the intents, so basically broadcast intents are delivered to everyone that exactly match that. So an intent is simply a piece of text. We call it action, but it's simply a piece of text, right? It may say, you know, what did we have in this case in the SMS example? So this is simply the piece of text, the action that we are filtering for. Android provider, telephony, SMS received. And it needs to be exactly 100% this match for it to be triggered, right? So that is in case of broadcasts. Now remember I said there are a couple of ways to send intents. You can say start an activity. So you saw that because that you can have competing handlers as well, right? So on receiver side you don't really have a competing. Everyone gets it. Yeah, I had 2 SMS sent, 2 guys got it, right? System and mine. On activity side I say start home. Well, if I have a competing homes, which one gets started? And that's where the system asks the user, which one would you like to handle this? Remember we had that pop-up and we said try the sample one, right? So similarly, yeah, so that's basically how it gets handled. So it's a totally different way it gets handled in that way. Not really. You can be explicit about the activity that you want to start. And in that case, there's no ambiguity, there's no resolving it because you are spelling out the class name of the activity. So if you want to start a specific activity, you should do that, right? And that was you know, that's kind of like what I was saying in that example with the intents. You know, if I'm inside of a Gmail and I want to open up a message inside my Gmail, I'm going to be explicit about which message I want to see, right? So I'm not wandering around trying to resolve it. So I'm spelling it out. There's no ambiguity there. So did you guys learn anything new? Was this like informative? Yeah. You know, I'm going to work on getting the videos up. There's also, I have a ton of more videos that cover entire 5 days, 7 days worth of training online. It's all free, so you can view it. I'll try to get the slides and everything up, you know, as soon as I get online and so on. Oh, please fill out the forms. Thank you.